All right, problem number 4 says to write each expression as a single fraction. Okay, so like we've been doing, the first thing we'll want to do is get a common denominator. And so looking at 4a, I have 2 times capital A over h minus a. And one point of emphasis here is that when you see a combination of, say, a capital A and a lowercase a, these are treated as different quantities. Okay, so I think about it as like an X and a Y. Okay, the case of the letter does make a difference. So let's go ahead and treat the little a as a over 1. And so as far as the LCD here, well, I just have h and 1. So the LCD is just h itself. And so I'm already set up with the denominator of h in my first fraction, but I'll need an h for my second fraction. Right? So let's see here. I have 2a for the first minus, and I'm missing the h. So I'll multiply this and this by h, giving us an a h there. And then I'll go ahead and just combine numerators. So I have 2 times capital A minus AH, and that's being divided all by h. And that would be it. All right. For part B, well, I have 4a squared and an a. So for our LCD here, my factors are I need a 4 and I need an a. And since the a shows up as a square in this first denominator, I'm going to need a square on the exponent there for the LCD. And so we'll go ahead and rewrite each fraction so it has this LCD for its denominator. So 4a squared and 4a squared. And so now, again, the first fraction's already set up for us. Has that denominator 4a squared. For the second fraction, though, I'm missing a 4 and a factor of a to get up to the 4a squared. So I'm going to need to multiply the c by 4a as well. So I'll write this as 4ac. Okay, so then subtracting, I'll get b squared minus 4ac, and then we're dividing all of that by 4a squared. All right, and that would be our answer for part B. For C, well, when I see a fraction like, or sorry, a number like 1 here, thinking about this as a fraction, you could think of it as 1 over 1, and my LCD here would just be t, because my denominators are just t and 1. So here I'm just going to multiply top and bottom by t. So in other words, we're just really rewriting 1 as t over t. So I get t, and this usually would be written as, or sorry, said out loud as t naught or t sub 0. That's a subscript. Okay, and then I get t over t. And so this would be t sub 0 minus t divided by that common denominator of t. Okay, so again, kind of like the uppercase, lowercase in part A, when you see t0 and t, okay, those are treated as different variables like x and y. Okay, so that's as far as I can go. All right, then for D, I have R1 and R2, and again, those are subscripts, so you want to think about these as, say, x and y. So I'm going to need to build an LCD, and to do that, well, my two denominators are just R1 and R2. I don't have a common factor there between those denominators, so as we said before, the LCD then is simply going to be the product of those denominators. And so here I'll just rewrite each fraction so it has the LCD as its denominator. And so then in the first fraction, I'm missing the R2. So I multiply this by R2. So we get an R2 up there. And then in the second fraction, I'm missing an R1. So I multiply the 1 by R1. So again, R1 up there. And then last thing would just be to combine the numerators. So I'd get this. And this is completely fine. The one comment I will make, and it's of course very minor, but this is really almost like an aesthetic choice. Sometimes you'll see textbooks insist on writing an expression like this, so the index is increasing as you go from left to right. So R1 plus R2, that's the same thing, of course, is R2 plus R1, just reversing the order of addition. And so you could write it this way, but both are fine. Okay, and then on to E, we have L squared over 6D plus D over 2. And so now to build our LCD, well, for the 6 and the 2, I'm going to need a 6, because 6 and 2 both divide into 6 evenly. And then I also have this factor of D. Alright, so then we can write each of these. So we have this 6D as the denominator, and that first fraction's already set up for us. And in the second fraction, to go from 2 to 6D, I need to multiply by 3D. And then I'm going to have to do the same thing up to the D in the numerator. So that's going to give us 3D squared for that new numerator. And now I go ahead and just combine numerators upstairs, and then we're dividing by that common denominator, and that's as far as we can go. Alright, great. That's going to do it for this problem. Thanks.